All right, let's take a look at the second homework problem from the 10.9 lesson packet. Again, this is used to check your work, score yourself, and then fill out the score report, okay? So let's take a look. A function f has derivatives of all orders at x equals 0. Okay, derivatives of all orders at x equals 0. P sub n of x denotes the nth degree Taylor polynomial about f at x equals 0. Okay, we're talking about Taylor polynomials here. Great. Gives me a point of reference for what I might need to do. All right, so part A here, what does it say? It is known that f of 0 is negative 4. I'm just going to write that down, probably useful. F of 0 is negative 4. If I'm dealing with Taylor polynomials, I'm going to need that probably if it's centered at x equals 0. And I know that p sub 1 of half is negative 3. P sub 1 of half is negative 3. So p sub 1, that's the first degree Taylor polynomial at half is negative 3. Show that f prime of 0 is 2. Interesting. This is starting to get at this Taylor series idea from kind of a different angle. They tell us we know what the first degree Taylor polynomial value is at half. We need to show that the derivative at 0 is 2. I know that the derivative at 0 would be used to make this Taylor polynomial, right? If I'm centering it at x equals 0. This derivative would be used to make this. So let me just write out sort of what I generally know then for that p sub 1. P sub 1, generally speaking, right, would be f of 0 divided by 0 factorial times x to the 0, right? If it's centered at x equals 0, I don't have a minus a or anything. Plus f prime of 0 over 1 factorial x to the first. Generally speaking, this is what the first degree Taylor polynomial looks like, generally speaking, for kind of any function, right? So let me fill in what I know then, and maybe this will help. F of 0. Oh, I do know that. That's negative 4. So that's negative 4 divided by 0 factorial. That's just 1. So this is negative 4 times x is 0. That's 1. So negative 4 plus f prime of 0. I actually don't know that. So I'm just going to leave it as f prime of 0 because I'm supposed to show that it is 2. So I'm going to leave this as f prime of 0 for now, divided by 1 factorial. So it's just 1 times x. So this is my first degree Taylor polynomial with what I know so far. What else do I know? I know that when x is half, so p sub 1 of half, negative 4 plus f prime of 0 times half, I know that this Taylor polynomial is negative 3 when x is half. So I'm just going to fill that in. And look, I should be able to now solve for what f prime of 0 is and verify that it is 2. All right, so I can add 4 to that side. That'll give me f prime of 0 times half is, adding 4 to the side is 1, multiply 2 to the other side, so I can see now that f prime of 0 is in fact 2. There we go. I've now shown that f prime of 0 is 2 simply by recognizing, okay, I know this would be necessary for my first degree Taylor polynomial. I know what the value of it is. Let me write out what I know about my polynomial, fill in my known information, set it equal to the value that we have when x is half, and finish solving. Okay? So there is part A. There's part A. Point-wise for this one, you got 1 point if you used p sub 1 of x, if you use sort of this idea here, 1 point. And then 1 point for going through the steps to verify, yes, f prime of 0 is 2. So this process here gets that 1 point down to the end. All right. Let's take a look at part B. All right. It is known that f double prime of 0 is negative 2/3, and f triple prime of 0 is 1/3. Okay, so now I actually have a fair amount of information for writing polynomials. I know f of 0 is negative 4. I haven't even read the question yet. I just write down what I know. F prime of 0 is 2. I also know now that f double prime of 0 is negative 2/3. I know that f triple prime, I lost a guy there, f triple prime of 0 I know is positive 1/3. What do I ask to find? Find p sub 3 of x. Oh, that's actually relatively easy to do at this point. P sub 3 of x just follows my Taylor polynomial pattern. F of 0 divided by 0 factorial x to the 0 plus f prime over 1 factorial x to the first power plus f double prime over 2 factorial x squared plus f triple prime, because I want third degree Taylor polynomial, f triple prime over 3 factorial x cubed. I like to double check because there's so many numbers here. I need to make sure I've not made a mistake. Okay, then we can simplify. This is our third degree Taylor polynomial. You can leave it, but that's not how you spell. Write the letter p. Combine it with a 3 also. Okay, p sub x. Simplified will be negative 4 divided by 1 times 1, so negative 4, plus 2 divided by 1 times x is 2x, minus 2/3 divided by 2 factorial is 2, so it's going to multiply 2 into the denominator there, which will cancel out with that 2, giving us negative 1/3 x squared, plus 3 factorial is 6, it's going to multiply into the denominator there, 1/18 x cubed. Negative 4 plus 2x minus 1/3 x squared plus 1 over 18 x cubed. All right, so point-wise here, this one is actually 3 points. You get 1 point for the first 2 terms, which you should have already gotten basically from part A. Then 1 point for the third term, 1 point for the fourth term. So this is a situation where, like, even if you'd messed up part A, I want you to plow through, like, keep writing, write what you know, and given the information we have here, we could at least get the point for our squared term and our cubed term based off the information we have here. So don't give up on it. Get down what you know, even if it means, you know, you don't get these 2 because you made a mistake in part A or something like that. Keep plowing through, write down as much as you know or you can do. You make up some numbers if you need to replace some things that you might not know just to make it look about right. All right? Cool. And then part C. All right, part C says the function h has first derivative given by h prime of x is 2x. And it is known that h of 0 is 7. This is starting to set up like another Taylor polynomial, but maybe for h. So I'm going to write down h of 0 is 7. I also know that h prime of x is 2. Ooh, not 2x. It's f of 2x. Is equal to f of 2x. All right. Find the third degree Taylor polynomial for h about x equals 0. All right, we know how to write Taylor polynomials and just need to get all the right information for h this time. So now I can say, okay, I have h of 0 is 7. What is h prime of 0? H prime of 0 is f of 2 times 0. So f of 0. What do I know f of 0 is? Well, I knew that f of 0 was negative 4. That was up in part A. F of 0 is negative 4. Okay. So what about h double prime? Because I need that. I need the third degree, so I need to go down to the third derivative of h. So what's my second derivative of h? Well, f of 2x is h prime, so I need the derivative of that. This looks like a chain rule. F prime of 2x. Take the derivative of the outside, keep the inside, times the derivative of the inside. There we go. So h double prime of 0 is going to be 2 f prime of, I'm going to plug in 0 there, which will be equal to, okay, 2 f prime of 0. Well, I knew that f prime of 0, I showed in part A, was 2. And if you didn't get part A right, you can even look up here to find it, okay? 2 times f prime of 0. F prime of 0. Now that looks like a double prime there. It's supposed to be a single prime. F prime of 0 is 2 times 2, so that'll be 4. Now I need the third derivative of h. So I take the derivative of this. Looks like another chain rule. That'll give me f double prime, but keep the inside, times the derivative of the inside. There was already a 2 there, so it'll be 2 times 2 is 4. So h triple prime of 0, lost another there should be triple prime of 0. H triple prime of 0 is going to be equal to what? It's going to be equal to 4 times f double prime at 0, f double prime of 2 times 0, which is going to be 0 on the inside. All right, which is equal to, do I know what f double prime is? I do, it was right here. So it's 4 times this, which will give me negative 8/3. Negative 8/3 is my value for h triple prime, okay? So I'm going to come back over here. There we go, negative 8/3. So now I just need to put all this together because I want to find the third degree Taylor polynomial for h. So I can call this like P sub H3 or something, however you want to call it, of x is, okay, let's put it together. H of 0 is 7 over 0 factorial x to the 0 plus negative 4, it's my first derivative of h, over 1 factorial x to the 1 plus my second derivative value was 4 over 2 factorial x squared plus third derivative is negative 8 thirds over 3 factorial x cubed. All right, pause a second. Always make sure you go back, double check, make sure you've not made some sort of mistake. Looking pretty good so far. Just checking my work, making sure I made a mistake. There we go. Now I gotta simplify this. So this means that P sub H3 of x is going to be equal to, let's see, 7 divided by 1 times 1 is 7, minus 4 divided by 1 times x is minus 4x, plus 4 divided by 2 factorial, that's 2x squared, minus 8 over 3, minus 8 over 3 divided by 3 factorial. 3 factorial is 6, so it's going to multiply 6 into there. That's going to give me minus 8 over 18 x cubed. Can simplify that a little more. P sub h3 is equal to 7 minus 4x plus 2x squared minus 2 can go into each of those, 4/9 x cubed. All right, there is our Taylor polynomial for our function h. Okay, that 4 started to look a little funny. Point-wise here, you got 2 points for applying this fact. So if you apply to this fact to find the derivatives, then you got 2 points. You got 1 point for the constant term, finding 7. That's why you got to keep plowing through. Even if you make some mistakes, keep plowing through. First term here, the constant term is 7, and then 1 point for the remaining terms. 1 point for, so it's 3 points total. 1 point for applying this fact to get derivatives, 1 point for your 7, 1 point for the remaining terms. Hopefully that helps. Be sure you fill out the score report and correct your work. Bye.